Okay, before the break, we were looking at binary search trees. That's one of our fundamental ones. Has a lot of advantages to work with as far as data structures, fundamental data structures. Has a lot of advantages, and it's really, really easy to work with. There are lots and lots of other ones. I was thinking about trying to go into them, but I was thinking binary search tree was going to go quicker than it was, and it ended up being we had to go a little bit past when we would normally take a break. An hour and 20 minutes before the break, just so we weren't in the middle of things. There are lots of other ones that we can build them ourselves. Those three that we looked at, I'm going to draw a couple quick pictures. We have other things like graphs. So instead of a tree, we have a connection, arbitrary connections. Maybe this one is connected to everything else. And we define arbitrary connections. So we have our node, and then which we call a vertex in a graph. The nodes are called vertexes, and we have a bunch of edges forming the connections to other vertexes. So each node is going to be our class, and then we have a list of edges at all the things that it connects to. Some of our fastest non-relational databases are node-based things. We get a picture that kind of looks like this. We define each connection, and then we can follow those connections around between things. That's called a graph database. I at least want to mention the name. What else do we have? There are lots and lots of them. Priority queues are just like queues, only we put the stuff in order first. Whatever the natural order for it is, alphabetical order, numerical sequence. If we define some specific greater than or less than qualities for our custom classes, it would put it in that order. And then it's a queue. It goes, instead of first in, first out, it's just natural order to go through it. There's a long, long list. With the trees, we also have what's called well-balanced trees, where we take time to make sure that it's as balanced as can be. We'll have exactly, for binary trees, we'll have exactly the same thing. So if we suddenly added 2 elements over here, we would need to rebalance that. So there's 2 on this side of this and 2 over here. So this one becomes our new root. And then we have 2 things on each side of that. I guess we go this way. So that our tree is nice and balanced. Takes a bunch of extra steps. The actual name for that is 2 Russian names that have a hyphen in them. So I'm not even going to try to say the name, but well-balanced trees. A good one for English. It was named after the 2 Russian scientists that invented it. And neither one of them is like single syllable Russian names either. It's the big long Russian names that we see right now. It's like, what? And
they're never single syllable names. I don't know. The only single syllable names the Russians got is Ivan. That's it.
Yes. Yes, and it's last names. It's a. I'm not going to try to pronounce it, but if you see if you see somebody talking about data structures with 2 great big long Russian names and a hyphen in it that are put together, that's a well-balanced tree.
I think there's a reason that a bunch of them are called Ivan, because I don't think they can pronounce their names either.
Yeah. A spanning tree connects all of the nodes into a graph. So we lead up to a graph. A graph could be all sorts of different things. We could have a central one with a bunch of nodes out here, kind of like a star shape. It's just called a graph, where we specifically define every connection along the way. So our node gets the value that's going to go in there, and then instead of left and right, it gets a list or an array of edges that connect to other nodes. And then we can traverse any of those edges. Special type of that is a spanning tree, where we take like connects all the nodes with minimum number of edges possible. Spanning tree is a graph with minimum edges. So if we had three things, like maybe A, B, and C, the minimum way to connect that, we would need two edges, right? Whether it went A, B, C, or A, C, B, or A, B, and C, we have to have at least two edges to make sure those things are fully connected. If we had something with four, I'll draw that over here. I'll call it A, B, C, and D. And to do fully connected, so that every single element knew about every single other element, we'd have to have at least six edges there, right?
That makes sense.
But to minimize that, A, B, C, D, minimal number, we could do it with three. It doesn't matter which three. I'll just draw two of them up here, because this, with three nodes, it fits up there pretty quickly. But no matter how we do it, the minimum number of edges we need is three. Could be these three, any other three. There are n to the n minus 2 possibilities. So on 3, it's 3 raised to the 3 minus 2 possibilities. So 3 to the first power, there's only 3 possibilities. With 4, it's 4 to the 4 minus 2, so 16 possibilities. With 5, it's 5 cubed possibilities. It grows very, very quickly. The different ways we could actually connect it. But you'll notice a pattern to that minimum number too, right? For that minimum number, if we have 3 nodes, we need 2 edges to connect them. If we have 4 nodes, we need 3 edges to connect them. Do you see the pattern forming there? We can always do it with 1 less. So it's not a complicated pattern. The last one I want to talk about, and these have advantages. If you study data structures further, these are the ones you'll see a lot of. That's why I mentioned them now in preview mode. Spanning trees have a lot of advantages, especially since they're a special type of graph data structure, not graph. Graph with like a verb, the ed, graphene, graph ed, like in past tense. That's the XY coordinate axis, like we do screen coordinates and like you learn in basic algebra. This is more of a modern math thing. Graph theory is kind of a modern math thing. So these types of graphs, it's a noun instead of not a verb. But our fastest non-relational databases are graph-based databases. And non-relational, so we don't have the nice table to fill out, the NoSQL thing. So we define those relationships specifically on how to traverse our data set. Last one I want to at least mention, because for those who have had me in earlier classes, I started drawing stack heap diagrams pretty early. And at SDEV 120, I started putting stack heap diagrams up there within a couple of days.
Yeah.
That's a good way to explain stuff. So what a heap is a special kind of binary tree. So a binary tree so that the root is the largest element. Oh, let me come back and add a word. A full binary tree. So we can't have those extra branches, right? We had some things where there wasn't exactly 2 branches coming off every node. And then that bottom row of leaves, there was an even number because they can't.
So it can't be a shabby tree. It has to be
That's a good word for it, Dave. Yes, it has to be a full tree.
full. Okay.
Tree.
You don't want a shabby heap Christmas tree.
Yes, every element, until we don't have any more elements, has to have exactly 2 things off of it. Which is one of the problems because our data set might not work out to the number to do that. So we actually throw extra data in there to make sure it's full. Because it's worth it to, what we get from it's worth it. So the root is the largest or smallest element. We also have to take time to figure out what the biggest or the smallest is. And then there's another order it has to go in.
I wonder if you can you fill that data like with a duplicate since you know it's gonna be, oh, okay. I
No,
didn't know if you could do that since it was probably, gonna be passed over anyway.
no, we use arbitrary data that will mess things up.
Okay,
But we can always find a value between them, right? If we have a 1 and a 2 and need to fill the branch between them, we can use 1.5.
makes sense.
Our data set's all integers. That's why we had 1 and 2, but nothing in between them. We can just throw a floating point number in between. And it'll fit the pattern. It does have to be that pattern we saw from the binary search tree, where smaller to the left, bigger to the right. So for like a min heap, there's one more criteria, and yeah, increases, and each level increases left to right, horizontally. That's what the binary search part is. Putting the word search there falls in, but it's not the same as a binary search tree. You get different advantages. So it has to be a full one. So for example, for a minimum heat of the set 3, 7, 9, 6, 8, 10. And then we're missing something, right? So that's where we would throw in arbitrary data. I'm put a question mark because we just have to make something up to have it there. It has to fit this pattern. It has to be between 8 and 9. But our data is all integers, so a floating point number will work there. Or there's various arbitrary things we can put there, but we can't really, duplicates cause problems. But it's all balanced out, and notice it goes in order this way and this way. As we go down and as we go across, it has to have both of those. And it allows us to jump to any particular spot. There's never any empty things. Unlike where we would keep cutting that tree in half to get there, we could go from the root to this element. Or if there was another row down below, maybe we have floating point data. So another row down here. We could go root, look at the first row, and that immediately tells us how the difference between the root And the first element in the first row tells us the difference between all those other rows. So
Would you already have like the one that's undefined with the question mark? Would it be able to have nodes that branch off from that without a value already set to it?
yes,
Or they would?
yes,
Okay.
because it has to fit that pattern.
Hmm.
And we have something that goes in this row, but we don't have the one that would go in this row.
Yeah, okay.
So
And that
we-
could be a floating point. Okay.
Yeah, we have to force it into this pattern, but then we check this. We see that distance, that gap, and once we know that, we can jump to this element. We don't need any other information.
Okay.
Or we look at that gap and we can jump to this element. Look at that gap, we can jump to this element. That gives us all the information we need to immediately jump any spot in the tree. It has to follow a lot of criteria. It's kind of hard to build. But yeah, we look at this, it's not even multiple passes like we saw last time. We look at that and then jump anywhere in the tree. That gives all the information we need to get anywhere in the tree. And we can do it with a max heap as well. Which I'm going to erase this because I think that's enough to kind of see the picture and start getting an idea of what it looks like. You can quickly, we looked at it the other day when we started talking about that structure, that way of the program, the tutorial site Programmies. Obviously they have heaps on there. You can look at it and see how to code it. It's a lot harder to code. That's one of the big things with binary search trees is we get a lot of advantages and they're super easy to work with. 11, 15. 10, 12, whatever, 14 and 16. All right, so once again, we know our largest element. We know where one of these branches starts, and we know it's perfectly balanced. So there has to be the exact same number of elements on the other side. And once we see that first bit, I think we'd look at this side of this time. For max heap, we'd look at this side, and then we know enough to jump to any element in there in the next step. They're a little more complicated to code up and maintain and update. And obviously, every time we do something, we have to rebalance. We have to rebalance our tree. We have to re-prune our tree. Right? Anything Tim mentioned the word shabby, that's really good. We can't have a shabby tree. If we need to change something, that's going to make our tree shabby. So we have to re-prune it every time we do something. Okay.
How do we rebalance it?
There's a lot of work to that. That's why we weigh whether it's worth it or not to put the heat together. Because it's not just a lot of work developing it, it's a lot of work along the way of using it and then updates and maintaining it. It's a lot of extra work. But that's the absolute best we can do from a tree. So sometimes it is worth it. Because it's really nice if we have 500 million data points to be able to jump to any single one of them in 2 steps. Right? That is a big advantage, but obviously that's a lot more work on our part. Not just when we first develop it, but along the way. And as we do things, it takes more work. You can look up how to code it, but it's recursive calls kind of like the other ones. But
So
just to
you said that on the min tree that we're going from the root to the left down, right? And then on the max tree, we're going from the root to the right down.
yes.
Is there any other difference between the min and the max?
Yes. But not for our class.
Okay.
Yes, because this is something that could be studied at the doctoral level. So there are other, yes, you can take this all the way to a PhD in computer science. So there's lots more to do than just the brief preview here. I'm doing the quick overview because I know those of y'all have had me since the SDEV 120 class. We saw the word heap show up early in the SDEV 120 class. So we're finally at the point that we can explain to give a rough overview of what it is and why it's advantageous. to answer questions that some may have been in your mind for a while. Right, I always draw those stack heap diagrams. And talked about what a stack probably talked about what a stack was in SDEV 120. But it just said heap is another data structure and didn't really get into it. Yeah, I'm gonna go ahead and erase that. It'll be a while before you have to make those. Anybody heading to a 4-year degree, I can tell you with certainty you will take at least one entire semester on data structures. And you'll spend a bunch of time on heaps. You will be given an assignment where you create a heap. And then after it's graded, you will be given another assignment to go improve that heap that you created the first time. So that's something that is going to show up to those continuing it further. It's a big structure for software development, right? This isn't computer science. We don't worry about those optimizations and stuff. Maybe sometimes we know they're there. Stacks and queues are better than having a list because it's going to dump stuff out of the thing. But let's look at an example. So let's work that into an actual example is what I wanted to do because I went from the other day. I'll go over to files. We did the standard thing for a classroom. We made a queue that isn't anything except a queue. And it looks like we're going to make another thing that should probably be built into the language, and it is. We have to import the queue library. A stack, what we've been calling a list this whole class is actually a stack. We just haven't used the pop method. We just haven't taken things back out of it. But it looks like we've made just a completely generic one. So it's not really insightful into what we would actually do with these things. So I wanted to do an example of that, which is also going to serve the purpose of, I have not planned this example, which something you all have probably noticed in class. This is quite often seems to go very, very smoothly. Right? Never seem to hit any logical errors in class. We hit typos sometimes. And y'all probably notice that's not how it goes whenever you're putting your homework together. That's not how it goes for me either. I just don't want to waste class time. So I do that ahead of time. But I do like to do that at least once in class so we can see, you can see that it really does go that way. It takes them back and forth. So let's make a new project here. First thing, I'm gonna make a class. I'm thinking a payroll thing. I'll call it Paycheck. That seems like a good thing. And first thing is we need the data class for our object, so employee. That's what we're going to need for. That's what we're going to need to do some sort of payroll, the data for all our employees. Class. I'll call it employee. Need some data fields in here. So self. What will we need for an employee? We'll need
Name, employee identification, date of birth.
that'll work. I'll cut it down to minimize. That's one thing, nice thing about payroll is we can extend things out. So date of birth. Well, I can use my regular thing, age and town. That'll take the place of date of birth and address because our deductions would change at certain ages, right? Our health insurance prices, premiums change at various ages. The amount we can contribute to retirement plans changes at different ages. There's a lot of changes along the way. So the date of birth needs to be there.
Yeah, and then the town, I guess that would change depending on for state taxes, how much you're paying out.
We want the exact address because we have to pay taxes all the way down, right? We have to pay federal, state, county, city taxes. We go all the way down. Usually the city in Indiana, I think in Kentucky as well, the city is wrapped up in the county, right? They're 0.5% they get from the county. That way it's one step less. In some states, when I lived in Georgia, there was just a state tax, and then that got passed back, a portion got passed back to the county, and then the county passed a portion back to the city. Different states do it different. In Indiana, we have the the state and the county, but we do actually pay at every level along the way. So that's what we need the full address, but for our example, well, kind of like age, it should be date of birth, but that's going to require an actual date, and for age, we can just put a number in, and that'll be good for a class example. I like payroll examples because Americans know how those work. And then what was the next thing you said, Kyle? What's the most important thing we need for payroll?
Employee identification.
Oh, that works. Employee ID number. Imp ID. I was thinking that, or maybe pay rate. We might need that number, right? So we can do our quick calculation. I guess when not a really quick example, we would probably, we would need some to make this one abstract and then have some subclasses of whether somebody's hourly or salary. And we do need different things that way. Self.name
Oh,
equals
yeah, because they don't get any overtime when they're salary, right?
not until it gets way over. Salary gets overloaded. But yeah, you have to go, the expectation is like not just 40 hours. Like there's no way you can do that in less than 60 hours a week.
Mhm.
That's where the first overload kicks in. So it can get bigger, but yeah, the expectation is if you're on salary, you're going to work a lot anyway. So if ID equals if ID. Self pay rate equals pay rate. Any other data fields we need for a stripped down example? Oh, probably deductions. We want to do, I'm just going to do it as a single percentage, but that's would actually be a very, very complicated thing, right? Like in January, you start into a tax bracket, and then once you hit a certain number, right, your first 16,000 is at the lowest tax bracket. Then after you've made 16,000, then you go up to the next tax bracket, then you go up, then you go up. So you have to you work your way up through the tax bracket. So that's very, very complicated. Then retirement accounts, withholdings, HSAs, lots and lots of other things that go in there. So I'm just going to put deductions in one nice little simple percentage. But hopefully you all know how to expand it when there's time, right? When we're not trying to finish this by 8:45 and it's already 8 o'clock. We don't want to have the whole example finished 45 minutes from now. And then that other thing, we know we have more than one employee. We're going to read in all of our data, process through it, and get it back out of RAM. So we want it as a stack or a queue or something. So I'm going to make it into a list. Self.next by default is none.
You forgot the self dot deductions.
Oh, thank you. Self.deductions. And then we can grab our stuff from the list, right? Oh, that's a stack. Where's list? So we have these things that kind of turn it into a list. Right? If it's not empty, we'll stick that, call that the first element in the list. Otherwise, we'll keep going. I guess we need an add to make it a list. Well, we can do the payroll ones, right? Self dot pay. Yeah, that's a good one for it. We need the self parameter, and we should have everything else in the employee data we need to do the payroll. Oh, wait, we need hours, don't we? Hours change. So we'll pass in hours. Then if hours is less than 40. We want to return hours times self dot pay rate.
There was something last time you had to do when it was less than 40 when you were doing the paycheck, or it was, I think it was, what was it?
Oh, that's for the overtime one. We can do it in a second, Deb.
Oh, okay.
This is just a regular hours, right? That's just hours times rate of pay.
Oh, that's right. And you think, because it was over, if it was over 40 and then we took out the 40. Okay.
Actually, I don't want to return this. So I'm gonna say gross equals that. Then do withholding is gross times our deductions, which is just gonna be a percent at this case. We'll say it's like 15%, and that's gonna include everything, and they could change for different ones. Oh, self-taught deductions. Oversimplification on it for classroom examples, but I think you all know, y'all could expand it from that, right? Withholding is going to be a big, complicated calculation, but still a calculation that you would have the formula for and could plug right in there. We'll just do a simple version. Gross plus withholding, and then that'll give us our net pay. And we'll calculate that in a moment, because that's what we actually want to return. But we want to do it more organized. Else, gross equals, anybody remember how we do the ternary? Can we do an if else in one line? Do you remember doing that? We could do this, we could go back and do that in one line. I think it was on the paycheck thing where we looked at that.
Was it the if and then everything was in the parentheses or something like that?
Square brackets, colon, parentheses. True, comma, false, and then our condition goes over in parentheses. Whoops, not that button. I went in the register and disconnected everything from OneDrive. And when I did that, the print screen button somehow on the next update on Windows, print screen somehow connected back to OneDrive. But I regularly break computers in classrooms showing examples because I know how to fix them. So I don't want it to be OneDrive where it could accidentally back up a large break on the computer. It took a lot of effort to not go to OneDrive anymore. If y'all haven't seen it, your desktop is not stored locally anymore. You have to go in the registry and create a empty desktop. So if we're over the 40 hours, then we get our regular pay, hours times self-pay rate, plus the difference. Oh, whoops, not hours. We get a regular pay rate for the first 40, and then we do hours minus 40 times the rest of it. So,
Times pay rate times 1.5.
oh, yes. Almost forgot that. That's what you were thinking of, right, Dave?
Yes. that and the hours minus 40 and then.
Yeah, there's more than one way. There's more than one way to put it together. There's more than one way to write out that calculation. Y'all probably know one other ways. If we look here, in algebra class, we would have things like y equals 40x plus
No, don't do it.
x plus 2 times x times 1.5. I'm just putting some numbers in there, but x is in both things, so we could factor that out.
Quadratic equation.
Oh no, we don't need a quadratic. It's linear.
It's a linear equation, yes.
Pay rate shows up in both of our terms. 40 shows up in both of our terms. And well, actually this whole thing, shows up in both terms. So we could factor that out and make that look a little cleaner. Or, well, I guess cleaner is relative. We could write, there's different ways to write that same calculation though. Then our withholding would be the same thing. Which actually would be the same thing, so we could do it after we get the gross pay. And this is that thing I was talking about, changing the mind, right? Changing our mind as we write our code. It's like, oh wait, instead of copying and pasting that line, we really only need to do that once. The variable's set either way by the time we get here. And then we have gross and withholding. So then net is going to be gross minus withholding. And we can return gross withholding net. And we'll just return all three of them. That's the numbers we need for our calculation, right? But we know we're going to have lots of employees and they're going to be kept in our database. I'm going to do a CSV file. We still writing CSV files. We just import the library. It's really, really easy. We bring that back in. And the only issue is once we write it to the CSV file with that library, we have empty row, every other row is empty. So we just need every other row somehow. But we want to do stuff like the next and the last for our employees, or turn it into a list. This is where we would use that list. Oh, why didn't it change? Nope, I shouldn't have changed anything since last night. So don't save those changes. Or we could use a stack. But I want to kind of keep a list. So every time we'll keep adding the next. And we'll do that with the recursive call. Define I guess it would be push things on the stack, wouldn't it? Push things on the stack. We need ourselves. We need the head of the list. And then the employee we want to push onto the stack. That makes sense? So I'm saying list, but eventually I know I'm going to treat this like a stack. So I'm going to pull off from the last thing on the stack. And this is how we would add to avoid all those next things. Kind of like we saw with the binary search tree, we would put it here. So if head is empty, if there's nothing there, then our employee becomes the head. That's the first one of our list. Head equals employee. Oh, wait. Yeah. Otherwise, we need to call this again with the next one. Otherwise, we want to push something on this stack. Well, we're still going to pass in the same cell. Actually, we don't need to pass in self, do we? We're calling it. So here we do self.push. So we recall this method. And then we pass in head.next and that employee value. So I said something at the end of the night to give it a try, see if you could figure out how to add that without repeatedly calling the next. Did anybody get something like that? You use list and repeated loops and try to selection structures to add it in. Really, we just need a recursive call. We just look at next and we keep going until we get to an empty next, and then we assign it. That makes sense?
It does make sense.
So sometimes recursion is easier than others. This is one of those cases.
So how does it start back up again if you end up having another employee? You just have to run it again or,
Oh, we're making a stack.
okay,
Let me put a picture on the board. When we process this data, we're gonna bring our employees in from the file. We'll stack them up. And then we'll find this one's paycheck. And then it's gone from RAM. We don't need it anymore.
okay.
And we'll find this one's paycheck and we pop them off the stack as we go down.
As we put them in, they pop off at the top.
Yes, and we don't need them in RAM or anything.
Okay, so then the next time we run it, if we had another one, they'd be added on to that one. Otherwise, if we missed someone, it wouldn't be a stack, and they just process that one because, or however, but it'd be a different stack. It's not going to be added because we
Once our
stacked
stack-
those.
Once our stack is empty, we would make a new stack.
Okay,
But I guess now we need to pop things off the stack. Self. Head. And that's all we need to know. We need to know where to start the stack and we'll just keep going to the next until it's empty, right?
Yeah.
If head is empty. Oh, wait.
and this is the part you just showed us on the board, right?
If the next one is empty, right, we're all the way at the top of our stack, so the next one's empty, then we want to return this. I think I meant to do that here as well. If the next thing is empty,
Which would be the bottom of the stack, right?
yes.
Okay,
Oh, no, this is the top of the stack.
so how can it be empty?
Well, this is the next element. We're looking to see if the next element's empty. And if it is, then we.
I'll go to the next employee.
So is head the top of the stack?
Mhm.
If head's the top of the stack, then head dot next is empty.
Okay.
Make sense?
Kind
Now-
of. I like the visuals.
Unprepared example. So we're not to the end yet, we're not yet to the end yet, Deb, either.
Okay,
Some of the questions, I am making this up as we go.
I'll be patient.
So, yeah, some of the questions don't really have answers now. Because, yeah, this isn't like our normal examples. But notice how we had to go back and completely change it. That's the sort of stuff you all see in your code that we don't normally see in the class, right? It's like, oh, wait, that is completely wrong logic. That's not going to work at all. That's not even looking at the end of this. That's not even looking at the top of our stack. So we want head dot next is empty. Then push this onto the stack. If head dot next is empty, then we're at the top of the stack. So that's the one we want to return. Return head. Oh, actually, we want to remove it, don't we? This is stack. We want to get it out of there. So top is head. Then actually, I want to look 2 spots ahead, because otherwise it might be hard to remove it. I'm not sure how to remove it quickly. So we look 2 spots ahead. Let me put it in a picture. We have our stack. So we want to look 2 spots ahead. It's not empty, so we go on to the next one. Look 2 spots ahead. It is empty. So we want to take off the 2 spots ahead's empty. So head dot next is the one we need to pop off the stack. And then head is the one that becomes the new thing. Make sense?
Yes, that makes sense now. It's something about the visuals. It really helps.
Yes, that's what I was going to say. You're probably not doing much of this because of everything you've done so far has been designed to fit in the classroom. But try it on the simple things, that way you know that's a useful tool, right? grab a piece of paper, jot some pictures or whatever down to help with the logic, because we're at the end of week 6 now. 2 more weeks of this class, and you're that much closer to graduation. And there's a big step at the end of classroom programming and modern programming, right? Because the modern state of software development is way, way past anything that can fit in the classroom. Right? They figured out the stuff that fits in the classroom. They had that logic mostly figured out by the 1950s.
So when we go into an actual job, is it more or less, hey, congratulations, you know the basics. We're going to teach you how to do the things that we do?
Some of them are like that. It's different in every situation, but it's much, much bigger projects. So the Facebook example, right? Last year, Facebook was in the news, and the news was doing the thing it likes to do and trying to say bad ways. And they said Facebook laid off 11,000 people. Do you remember seeing that in the news, Kyle? I think it was around November.
And not only them, but there was a bunch of people that laid off tech employees.
The other companies, it really was layoffs. With the one for Facebook, those 11,000 that Facebook laid off, the appropriate way to say that would be that in 2021, Facebook hired 43,000 programmers to work on one project. That project finished.
Yeah, I remember you telling us about that.
Facebook only needed 32,000 programmers. That's different than a layoff, right? A layoff's like when cars aren't selling, so Ford has to shut down the assembly line. So that was just the news put it in a bad way. The project finished, and they only had, the next project was only going to require 32,000 programmers. So there's the stuff you just mentioned, right? You got the basics, they'll show you what the way they do it in their company. Or you'll be part of a massive, massive team working on those things like that project. So the news reported that bad, but saying that with what actually happened, talking project to project, those people were only hired to work on that project. So at the end of that project, they knew the job was over. It wasn't they weren't signing on for 40 years at Facebook. They were signing on for one project. And when that project finished, the next project required a lot less programmers. So that's just the news doing bad things, trying to.
Yeah, it's almost like they were contractors just to complete the project, not necessarily laid off, but okay, thanks.
Their contract ended. That's not a layoff, right? When you finish building the house, that doesn't mean you got laid off because you finished building the building. Right? The construction project finished. Those people are not laid off. They finished the contract. So it's things like that. And that's the modern state of software development. It's just huge, massive, massive, massive projects. So you would be put on a team to do little pieces like this. And you would come up, every team's different, so I don't want to dive into it too much. But does that give you a better idea of it, Kyle?
Yeah, I'm just, a lot of these things I struggle with implementing, especially when I'm going through the homework. Like tutorials are fine. That's just, hey, this is how you do this step by step. But when it comes to, hey, okay, take that tutorial and make something else,
that is why I'm doing this example right here, because tutorials, and normally in classroom we would have this, right? It's like, this is how you make a list, and then it moves on. So I wanted to actually show how that would apply. So we're hired for, I'll use that word, it was just thrown out. We've been contracted to make a payroll application. So we need to do that, and we think, well, there's a lot of employees, maybe it's a huge company, tens of thousands of employees, so we don't want to, when we bring in all of this data tens of thousands of times, we're going to burn up some pretty large RAM chips pretty quickly, right? Tens of thousands of employees with this much stuff is going to fill up most RAM chips very quickly, and everything else that we're going to payroll.
And if you're one of those tens of thousands of employees, you're probably going to do the same thing over and over and over and over and over again.
Yes. So this one, even if we don't finish, this is probably a better example of what we would do in software development. your part on that project, they would say, okay, you make the employee objects. And you're going to start with the basic stuff here, and then periodically throughout the project, other teams are going to send you an email that says, oh, can you add a data field? Can you add this data field? Can you add these 3 methods? Oh,
So
that first method you did didn't work. Can you add an extra return on that? Does that make sense, Kyle?
yeah. So what you're saying is in an actual contract, because we'll continue using that word. You know, your job could be to use our example, define the initial, and you're contracted. Okay, start with self, name, age, and town. So you make all that, and somebody else will come along and say, okay, well now I need you to add employee ID, and somebody else will come along and say I need to add pay rate and deductions, and on and on and on it'll go until you're done.
Yes, exactly. Yeah, and those would come from different people. So like pay rate and deductions would probably come from the person assigning the calculations. Whereas the request for employee ID would come from the person working on the database. Because for everything else, name would be sufficient. But the person with over in the MySQL server probably wants an ID number, a unique ID number for everybody. But yes, this is how it would go. It wouldn't be those generic stripped down examples just because they fit in Pi. Okay, so getting back to our example though, any other questions about that? Does that make sense to everybody? This is the sort of thing you would be doing. You would get a job, you would get that particular assignment on the team. I mean, you finish it, you get another assignment. After this, realistically, there'd probably be a pay stub object that makes it look nicely, that prints it out nicely. Somebody's on that, and all the connected stuff, and then the project manager is keeping it all organized. So it's things like that that take long periods of time. Like the team's going to work over months, and you're not going to. Well, if this was our contract, this isn't the only one we would make. We would make 10 different versions and see which one's the best. So compare them side by side, along with what other teams are doing, and see which one of the objects is best. Slight differences can make a big difference. Small changes in the text file can make a big difference in what happens. Remember, we saw a little bit of that when we looked at disassembler the other day. There's a big difference between multiplying and dividing when we get actually to what the machine itself is doing. Okay, so now back to our stack. So to pop things off the stack, we need to look 2 ahead. So if 2 ahead is empty, then head.next is the top. So then we'll store that, and then we'll say head.next is none. So we'll erase it from our list, and then we'll return it. Otherwise, if 2 spots up, so like if we're here at the bottom, 2 spots up is not empty. So we need to make this the new bottom and look 2 steps ahead, not empty. This becomes the new bottom, look 2 steps ahead, that's empty. So our else is a recursive call. We want to call self.pop with, well, we're not at the top, so let's just go to the next element and keep going until we get all the way to the end. And then when we get to the end, we've returned all the elements and took them off the list. Does that make sense? See how there's not really much to it.
Yeah, the pop makes sense. These make sense, especially once we see it on the board. So, but it makes sense now because you explained it before. I think last lesson you explained it. So now we can see it on the code.
We want to see it in different situations.
Mm-hmm.
It might make perfect sense the first time you see it, but that's not the only way it can be done, and the only way it can interact with other stuff as well. Mm-hmm. We want to see it in multiple places. Because when we did push and pop on the regular list and it's built-in methods, we didn't have to make them ourselves. But notice how we now have a list and a stack with the only things that we need to happen. Add things onto the list, push things onto our stack,
And
pop it off the stack, and then when it pops off the stack, then we'll calculate the payroll. Which is actually what we'll probably do down here. Yeah, actually, I'm gonna do that.
Okay, let's see how you would call this.
So then let's get the hours. Print, oh, wait, there's an input function, isn't there? Hours equals input. How many hours were worked this week? And it's behind Zoom buttons, so I have to type that without being able to see it. And move those up there. So we'll get the hours. And then we'll find, well, then we can just say comp dot pay with hours. And then we pull it off our stack. Calculate the one thing we want to know about it and throw it away. Do you see the benefits of that? We're not wasting RAM. We build up our list because that's all we need. We need to put them in a list, then go through that list and calculate pay. Build up our list, and when we grab the next element, what we really grab is we look at it, feed in the hours, get the pay number, and throw it away. And we'll get each one of our things that way. Hopefully that helps a little bit in seeing it in the bigger picture. I guess now we need to actually do this. So I make a new one. I'll call this add employee. Fill dash workforce. That sounds like a good name for it. .py. So we'll fill the workforce by saying next is, I probably shouldn't use the word next. Well, I know I'm going to do from employee, import employee. Definitely need one of those. And I also want to import CSV to create our database to keep them around. Because we don't want to do a new employee every single time, right? We're going to keep that around in our database. Put in some pieces together. I don't know, X is input. Oh, I just realized something. I might have to jump back over here. Hours is going to be a number, so we better turn that into a number. And notice I didn't wait to do that. As soon as it popped in my mind, I went and did that. That's another thing from the years of practice at coding I learned. As soon as you realize that, don't think, oh, I'll do that after this. As soon as it pops in your mind, jump over to the other file and change it then, because you will not remember. You will not remember 30 lines of code from now when you go to run it and it's going to crash.
I can concur.
So input, is there another employee? Yes or no? If X dot lower is equal to yes. Well, I don't need to know first. No is the shorter one. So if it's no, then print, then have a, actually, I just look through it. We'll just look through it. We don't need a message at the end or anything. If, or while X dot lower is equal to yes, with, oh, we need to create it first, don't we? Name is input, enter name. Or make that look a little bit better. Age equals input. Enter age, or more realistically, like I pointed out earlier, enter date of birth. And we probably have to go with some specific formatting thing that we can change to make sure that it goes in there. And then we need a big complicated selection structure to make sure that works right.
Yeah, I was thinking when I said date of birth, okay, now we're gonna have to import the module for date and time. And then if we want age, we're gonna have to take date, time minus date of birth equals current age or whatever. And it was just gonna be this whole thing, but age is definitely a more simpler thing to use, especially for this example.
And that's what we would really want.
Kyle.
And then we'd also have to worry about users giving us the wrong input, right? My birthday is October 27th, 1978. How is that entered? Is it like I just said it? Is it 10/27/78? Is it 10/27/78 or 1978? Is it 10-27-1978 or 78? Right? We have to, there's a lot to get the date of birth in there, but they're all obvious, right? It's an obvious lot, so it's an easy expansion, and we can simplify it for the classroom. Do you have a question, Danny?
Should we go ahead and put int on the age?
Might as well.
So that means you're a Scorpio? So you're a Scorpio.
If that's the date for it. So what else do we need? Town, employee ID. Town equals input, enter town, or more realistically address, but we can simplify it for this evening. Should we just enter employee IDs? That's not, I guess that's taking the place of social security numbers, right? Because really we would need the social security number or the tax
Yeah.
payer identification number. I don't know why I had to think so hard about that. It's not like the IRS is created with the number. I remember TPI, taxpayer identification number is implied there. I felt awful hard for a name the IRS created. ID equals input, enter the last 4 digits of social. That's what we usually use, right? Seems fairly typical. What else do we have? Oh, pay rate and deductions. Rate equals input. Enter the rate of pay. Which this stuff would go much, much nicer in a GUI. I think everybody knows that, right? Let me highlight that. Grab some parentheses around it and turn that to a floating point number. And deductions equals input, enter the percentage of deductions, withholdings. That way it sounds all formal and stuff. And then again, wrap that in some parentheses. And turn it into a floating point number. As percent. And then we can do divide by 100. Afterwards, so we'll take the integer and then, well, could be a fractional number, right? We'll take that like 14.3% or whatever, and then just divide that off. We probably want to put a lot more care into making sure people entered that number correctly, but
So would enter it as a 2-point decimal? See?
I'm sorry, what?
Okay, so it's saying on there to enter it as a percent. Are they gonna be using the percent sign? Or is it gonna be like a 2-point decimal?
Percent sign, I believe, will be dropped.
Okay,
Certain symbols, it knows it will automatically drop.
okay,
The ones that would, that normally go with numbers. So if we say 23.4%,
mhm.
cast that into a floating point, I believe.
Oh, okay.
If not, we would just need a selection structure to parse through it.
Mhm.
But for our case, let's just not enter the percent sign here.
Okay,
Real situation, you would need to do that. For sure. That gives us enough information to create an employee object, right? So let's call it temp is an employee. Oh. Let me erase this line. I'll come back to that after I fix this error. I didn't even notice the,
It's still an error. Why is it upset?
Oh, because
Oh.
yes is not. in-
yes, it should be a string. Okay, there were two errors in there and I didn't even notice the second one. We need to make sure it's exactly the string, yes. Okay, now we should get the predictive text. Temp
That's
is
something I like about Spider is that it does that little red X thing and lets you know, hey, I see something that's not right here. You know, when I was working with idle, you know, you don't find out when until you run it and something's wrong.
yeah, well, it's not giving me the predictive thing. So name, age, town, imp ID. Spider will also pull from that class and give us the predictive box, but not right now for some reason. So name is name, age, town, imp ID, rate, and deductions. And then we can write that to the file with open workforce.csv for append mode, because putting the right file writing here, we don't want to overwrite the one we did the last pass through the loop. Make sure we're in append mode as to file, then CSV dot writer, and we want writer equals CSV dot writer for that file handler. So now we have a CSV handler, not just an arbitrary file handler. Then we can say writer dot write row. And really, we want those data fields in the form of a list here. Right? We'd have to go to a binary file. We could use our object, read back in the binary object. But the reason I did it this way, oh, I guess we don't even need this line here. That's for when we read it back in. When we read it from the file, which we're going to do here in just a second. But to go to a CSV file, we need a list. Sorry, I probably could have zoomed in a second ago. Or at some point before now. So we need a list, and we will send the stuff in that order. Name, age, town, imp ID, rate, and
it
deduction.
has to be in that order in this list, right?
So actually, I don't think we need to we don't need to worry about the casting here. We could have done that later when we read it back in. Because we're always going to read, this is just to add employees. So now,
Okay.
let's fill the workforce So that will create our CSV file. So I think this is the first, now we're up to a point we can run it. Let's see if this works. Is there another employee? Oh, whoops, no, we're not ready. We do all that, and then we need to ask, is there another employee? And either yes or no. And when there's not, then we're done looping. So let me save that and cancel this run. Is there another employee? Yes. So let's say Sally, who's 32, lives in Salem. Last 4 digits, 1234. And Sally makes 12.34. And let's say she has 19.3% withholdings. Is there another employee? Maybe, but I'm going to click no for now. So I can check here and see that yes, workforce.csv was created. Spider doesn't like the fact that it was created on a Windows machine and did carriage return line feeds. So it just, that if you didn't read that error message quick enough, Spider said it has mixed line endings. So Spider will go ahead and fix it now. So Sally 32 Salem. So that's all the information we need. Okay, we don't need the employee object. We just need the data for it. So it looks like that worked. So I'm going to close this. Look, because Spider made those changes, not me. So Sally's in there, so we can probably add some more. Is there another employee? Yes, there is. How about Chuck, who's 52, 53, coming on retirement age, lives in Charlestown, 5678, rate of pay. He's been at it a while. He's got a lot of yearly raises. So maybe he makes like 31.23. Got a lot of savings, so he decided to increase his 401 deduction or something. So there's maybe Sally's taking only the tax bracket out, but he wants to add the full 15% he's allowed to the retirement account or something. Let's say 38.9. So his taxes are like a third of his thing, but that's all withholding. So that's health insurance, which is definitely higher for a 53-year-old than a 32-year-old. All of those things. Yes, there's another employee. How about Lou, who's 44, lives in Louisville, 4444, 2121 seems like a good thing, and I'll just do 19%. Yes, enter the name. I don't know, Alan, who's 22, lives in New Albany, 2323, is ready to pay, well, match his social security number, and I don't know, 14% withholdings. No dependents, nothing he needs to worry about or anything. No garnishments or anything at 22. They'll show up later in life. Maybe one more. Yes.
Kyle,
What's that?
Kyle.
Kyle.
Yes. Pronounce my name. I can't spell my name.
I can't spell your name without looking at it.
His mic might not know his mic's on.
I'm just making up a number here.
Okay.
For, I know a town for Kyle, Shepherdsville, which I probably spelled wrong. 567, oh, I think I already did 5678, didn't I? 3334. That's a good pay, and
Yeah, that's not bad.
1% withholding. That gives us a nice little data set to work with, right? Hopefully. Oh yeah, it looks like we got a nice little data set to work with. That'll be enough. It would build up quickly. So now we can do the actual, now we're to the actual application we were setting out to build. Right, we set up our data, built our database. Now we can start trying to calculate payroll. So save this as payroll calc.py. And from employee, import employee with a capital E. And let's read in our database. Import CSV. So with open, well, should probably copy this over here so we don't make any typos. Because we could have spelled the name wrong when we created it, right? Computer doesn't know how to spell it, so copy and paste, and then typos don't even matter. This time we're reading as from file, and reader is CSV reader, which just needs to know what file it's reading from file. For row in reader dot read. What?
Does it need to have a colon after from file and then indented in on 16? I don't see any other.
I'm not sure what that error message was.
Okay.
I'm not sure how my cursor, I didn't think I was doing anything in the console.
Hmm.
I accidentally put my cursor there and hit enter, so I don't know what was in the console when I typed enter. No, I think before we would put that into a list and go through it, right?
Mhm.
For each row in that list, we can just check if row, or the other way, isn't it? In Python, if length of row is not equal to 0, that's that every other row in the CSV thing. There's more than one way to check that. That's the way I usually do it. If it's not 0, then we have one of our rows. Then we know that the order is in, so I'm going to open that up so we can look at it. Name, age, town, employee ID, rate of pay, deductions. So it's the order we need it in. Name, age, town, employee ID, rate of pay, deductions. So really this is where we need this line. So I'm going to cut it from here. Go ahead and take that out of there because it wasn't doing anything on that one anyway. We'll paste that in. And then name is in row. Whoops. Now my cursor was over here. Name is in row index 0. Age is in row index 1. And I can probably just copy and paste that to avoid typos. Town is index 2. Employee ID is index 3. Index 4. Index 5. There we go. So there we got our temp one. And now we need to add that to our employee, right? So
What is TMEP again?
temp as in temporary.
Oh, okay. It's on there, it's TMEP. Is that gonna mess up anything in your code?
Oh, no. It's just a variable.
Okay,
It's not a keyword. It's temporary, isn't it's gonna be deleted on the next pass through the loop. So it won't hurt anything whatsoever, unless I was.
unless you were to have to reference it somewhere else.
I'm gonna keep the typo there to show that
Okay,
it doesn't matter. We probably should retype it because that makes debugging harder. But it's just a variable name. Call them whatever we want.
okay.
Adding that to the stack might be a little bit difficult, right? So I want to make another employee that always falls at the bottom of the stack. That is always the head of the stack. And then when this is the one that'll be the base of the stack. So the boss. That's not just a temporary employee, right? The boss is part of the business. So like an owner operator, right? He's not just a temporary employee that comes and goes. He's there till the day he dies. And hopefully the business outlasts him. And then maybe one of his children will inherit the business and they'll be at the boss role until the day they die. And then it'll be a nice long running business or something. That's always the hope, right? So employee, boss man, for a name, age, let's just make it middle-aged. What was next? Rate of pay? Oh, I can look. Oh, town. Really, this is just this one we don't even need, right? Employee ID is next. So I'll say 0000, and then rate of pay is 0.000. So that way it doesn't affect anything. It's just something so that we have a nice, clear reference for the bottom of our stack. We run that through the calculator and it's just gonna calculate 0 times a bunch of things and return 0, right? So we don't necessarily need to worry about that. 000, and then deductions is 0%. So once we have our temp employee, then we need to do boss, which is really the base of our stack. Base might have been a better name. And we want to push that boss object and then that new employee. So there is a redundancy there that can be cleared up. Boss and temp, which I'll just use the predictive text list and act like I don't even know how it's spelled. But typos don't matter as long as we spell it the same way.
Right, okay.
As long as we keep making the typo in the variable name. In a keyword,
It could have been Y, as long as you used Y again, okay.
Yeah, in a keyword, that's very different. We definitely don't want to make a typo in a keyword, but for our variables, as long as we spell it the same way every time, it's fine. So that should build our stack, right? There could be errors here, and I don't want to spend a lot of time debugging this, but this process makes sense. We haven't seen very much of this, putting these together. So instead of a list, we made our own custom list that only has the functionality we need. We're all the way up to building it. So now, while boss does not equal none, we're gonna need to pop things off the stack, right? And we know we'll be done popping things off the stack when we pop that last thing off the stack. Or boss becomes none. Print boss.pop. And that'll give us all all our stuff in order. I guess we should have returned the name too, because now we're not gonna be able to tell who it goes with. But it's coming on 9 o'clock, so extensions can add later. Anything else we need? I see the people in the classroom trying to shake their head no, they just don't quite want to yet. Oh, we built it all into our stack. Our stack, we have a specific purpose stack. It's not a general stack like a list where we add stuff to it or take it away. Or even if we left it as a list. It's not a general purpose one. We built our specific purpose into that list, or in this case, the stack. So when we pop it, it's going to return gross, net, right, gross withholdings net. We probably should have returned name. It's going to be hard to tell who that goes with, right? Return.
So
gross.
it's gonna go through it, pop each one of them off until it reaches none, which is where it's done, and then.
Yeah.
Okay, until it reaches none and it's done. Okay.
Can't guarantee I didn't make any typos here, but that's why I was talking through the logic. Hopefully that the general process makes sense and the idea there makes sense, because it's coming on 9 o'clock. I don't want to spend a lot of time debugging this. Does anybody have any questions about those processes before we go through and debug this? Or check to see if it runs? Because we probably shouldn't have got all the way to the end before we tried to run it. That is probably the worst thing you can do in software development, right? Is try to write the entire piece of software before the first run. But that's what we just did. Let's see. Let's see how it went. Uh-oh. CSV object has no attribute read. CSV.
Kind of frustrating when you don't have all the knowledge that you have. I would be stuck right here and be like, okay, I have no idea what to do now.
Reader. So my first try is I'm going to check predictive text. CS is probably read row. CS vote b dot reader dot I don't know the keyboard shortcut to get predictive text if it doesn't give it to me here. But I do know this. Control I. CSV is part of our default thing, so we should get this. CSV reader. Reader with an iterable it takes in, which is the file handler. Oh. I don't need to say read. Read is automatically implied in our reader object. So the example there just says CSV reader. In Spider, I hit Control I to get the help menu right here.
That's good to know. I probably hit every error that Python's ever made.
I know so much about Python because I've seen so many errors. Oh,
Well, that's good to know.
well, yeah.
Hopefully that makes me better too.
We don't learn anything from the stuff we get right.
Right.
A text message where you copy and pasted or took a screenshot of the error message. I answer those so quickly because I've seen those error messages more than once.
I like that. I like that a lot.
I didn't just like read a textbook and then automatically know everything there was to know about Python. Python here, we're in 3.11. Right? That's our new console. This has technically only been around since October. There's not been time to learn about everything in there. So I've been very, very busy since October. Right? So it's from the mistakes as well, right? When you send me a question with an error message, I answer those so quickly because I've seen all those error messages many, many, many times. I've seen them way more times than you have and dug the digging around and figuring out what they mean. Oh, you got a couple typos fixed all the way to the end of the software, and
Yay.
So yeah, even after decades of programming, I'm still really proud and excited about that. It's like, wow, only 2 typos. That I'm counting that as works on the first try.
That's awesome.
2 errors is 2 errors and 4 different files is nothing. Or 3 different files, and some data storage. How many hours were worked this week? We probably should have worked names in there. So we have to know whose name's who. So I'm just going to make up. Can't multiply sequence of non-int by type floats.
You have to make them both strings again.
Where do we ask that?
Employee line 20 or
How many hours were worked, turned it into a float, and then we multiplied by rate of, let's make sure that this is where we need to cast them as integers. Or numbers.
Both of them.
Anything that's a number.
Okay.
That we might do math with.
All of them. Okay. So integer float, or does it? Yeah, because age can't be a.
Well, age
I
could be
guess.
number, but we'll just, age should really be date of birth. But employee ID is all digits, but it's social security number. We don't do math with social security numbers, right? Your social security number plus your sister's social security number doesn't tell you anything about your brother.
Right.
It's meaningless.
Yeah, so it's just a string.
Yeah. So, and if it comes at this point, if it's already a number, it doesn't hurt to cast a number into a number. This is that final step, but by here, it has to be a number. So 3 errors, that's still not bad, right? But notice the errors worked in. Probably should have put in names while we were there. How many hours? Let's change that to an F string. And instead of work, say did self.name work this week. That wasn't really an error, but we might as well fix it while we're here. So how many hours did Bossman work this week? Well, Bossman didn't work at all. How many hours did,
He'll still get paid his salary.
something didn't go through. Let me see what we have at this point. Breakpoint, close this out. So somewhere it didn't white build our stack. So Bossman worked 12.
Does the fact that his hourly rate is 0 have anything to do with it in the
That-
variable boss?
things aren't getting pushed on the stack for some reason.
Oh.
Print on the file, make sure we find the file. Get our reader from row in reader. Print row. And once we have that, print TMEB, which is supposed to be 10. Stop that run. We should have that all in there.
Yeah, list of employees.
So it created all the objects successfully.
Mhm.
I guess we need to try and print the whole stack. Is there a way to do that?
Can you do print asterisks or something with asterisks? Is there any way?
I'd have to make a whole print method.
Okay.
Things aren't getting pushed on the stack. That's gonna need debug. I'll have to do that later. That's the sort of thing that normally gets done ahead of time in class. I'm gonna have to track down that method, and my first thought is to create some echoes. I put a break line right here and it did not pause when it hit it. Oh wait, I forgot, I used the wrong play button, didn't I? I need to debug it, so y'all know how debugging goes. But that's why I was talking about it the whole time through, because we haven't seen very many examples like this, actual examples. Does that give you an idea of what we would do with this sort of thing?
You did a good job, Chris, and I'm glad that you ran into this because it helps us too. And then maybe if we can get a follow-up to kind of see where it is, maybe you can send us something in the announcements and then we can take a look at it. But overall, I think it helps a lot to see you do it from scratch.
I was getting ready to say, see if you can debug it.
Ah!
It appears that nothing ever gets added to is not getting pushed on the list. So see if you can track down where things aren't getting pushed on the list. We pass in our basic level.
Okay.
If the next thing is empty, we add it to that. Oh, we never. Yeah, I might look at, I don't know when I'll have time. Might try to look over it. We can dig through there. We talked about it. See if you can find the error. That'd be good practice. It's not a requirement.
Okay.
What's the homework assignment worth? Are they 20 points, 40 points? I'm behind on grading in this class. Or is homework assignment is 40 points? 20 points?
Some,
Depends. Labs are 40 and case studies are 20. But yeah, I'll definitely try.
Okay, the 20 points extra credit if you can debug it.
Yay, thank you. Well, that's generous, but we'll see.
Okay, case study. So see if you can get that, see if you can track down and fix that bug. 20 points if you can track it down and fix it. 10 points if you can just track it down. Sound good to everybody? Track down the exact line it is.
Yes, sir.
Yeah, by next Monday. I guess then we'll talk about it in class next Monday. Or send it to me, but try to track it down on your own. So for your own work through it. It's originating here, so something went wrong with that push method. Y'all want to check through that, dig around, see if you can figure it out. Get some extra credit points if you do. But I wanted to work through an example, and it's kind of nice that it didn't work out because that's what doesn't happen in class when I practice ahead of time. It's like, oh no, we're out of time, and the example we're making up right now didn't work out, which is kind of rough.
Because it happens a lot for me, so it's good for us to know that we're going to be running into that as seasoned programmers.
Yes, it still happens. We still figure it out as we go. Every problem is a new problem. What you learned before might help, but it might not. That's the nature of problem solving. Every problem is a new problem. Anybody have any questions before we wrap up tonight? Okay, I assume 5 seconds of silence means no questions. If you have any, let me know. 20 points extra credit if you can get that bug fixed in that. It will be on GitHub It will be on the GitHub link here in just a few minutes. As soon as I stop the recording. But I think 5 seconds silence means no questions. So you all have a good weekend. I will see you on Monday.
Thanks, Chris. Have a good weekend.
Send that to me when you get it fixed.
Bye.
I know you all can fix it.